All right, let's dive right in. If you've been anywhere near product development lately, you know that slapping AI into an app is, well, it's a completely different beast than writing traditional code. Today, we're unpacking a really fascinating piece from the Specky blog. It's all about this massive shift from traditional product management to what they call eval-driven product management. I am so genuinely excited to guide you through this because figuring out how to actually define good for AI features is rapidly becoming the single most critical skill for anyone building tech today.
Here is our blueprint for this explainer. We've got a clear 5-part journey. 1. Why AI pilots fail. 2. Buttons versus probabilities. 3. The power of evals. 4. Building your first eval. And 5. Shipping with evidence. Let's get to it.
All right, Section 1, Why AI Pilots Fail.
95%. I mean, just think about the absolute mountain of time, money, and engineering muscle being poured into artificial intelligence across the globe right now. It's wild. Yet, despite all that buzz and investment, we are staring down a 95% failure rate for enterprise Gen AI pilots. Most of them are just crashing before they ever cross the finish line into successful, value-generating products. So what is actually going on here?
Well, there's a 2026 finding from MIT that really puts this into perspective. It states that 95% of enterprise Gen AI pilots deliver zero measurable ROI. Now, our first instinct is usually to blame the tech, right? Oh, the models hallucinate too much, or the latency is just awful. But actually, scratch that. This is almost always a product judgment failure. It is not an engineering issue. See, most teams are shipping AI features the exact same way they ship a traditional static drop-down menu. You write a spec, you build it, you click around a bit to see if it works, and boom, call it done. That fundamental mismatch in process, that is exactly why the ROI is sitting at 0.
Which brings us to Section 2, Buttons versus Probabilities, and really redefining what done even means.
So, we're moving from deterministic features to probabilistic features. Look, for a deterministic feature, say a save button, defining done is a piece of cake. The button either saves the form to the database or it doesn't. It's totally binary. But AI features, like an automatic call summarizer or a RAG-powered answer bot, they are probabilistic, meaning done is no longer a simple yes or no, it's a whole distribution of outcomes. You can literally feed it the exact same prompt with the exact same model and get a completely brilliant, insightful answer on Monday and just absolute confident nonsense on Tuesday.
Because of that, our old tools for defining software just completely fall apart. Back in the day, handing a product requirements document, a PRD, to engineering that just said, hey, summarize the customer call, was perfectly fine. But tell an AI model to do that? Completely meaningless. If you don't define exactly what a good summary contains, exactly what a bad one looks like, and this is crucial, how many bad ones you can stomach before the feature is just dead weight, your engineers are flying entirely blind. You aren't defining a product at that point. You're just kind of crossing your fingers and hoping for the best.
So how do we fix this? Section 3, The Power of Evals.
Enter the eval. An eval is basically an executable user story. It's a set of test cases where each case has a specific real-world input and a super strict rubric for grading the output. I absolutely love how the source material frames this. Evals are the user story for a system that never behaves the same way twice. A traditional PRD tells your engineering team what to build, sure, but an eval, that's what actually tells you if the thing they built survives contact with the messy real world.
Now, I know what you might be thinking. Testing models? That sounds like something my machine learning engineer should be doing. But nope, evals sit squarely on the product manager's desk. Think about the comparison here. An engineer's job is to make a model run faster or ace some general academic benchmark. But making a product call? That is deciding which specific failures are actually going to cost you money or churn a real customer. Take an AI refund bot, for example. An engineer can easily make it sound friendly and chatty, but it takes a PM to say, okay, this bot can ask clarifying questions, but it can never, ever invent a fake return policy. That is pure product judgment. The eval is just the place where you write that judgment down as code.
All right, let's make this actionable. Section 4, Building Your First Eval.
Here is your highly actionable 4-step playbook to go from squishy vibes to hard numbers. Step 1, collect real inputs. Step 2, grade by failure mode. Step 3, set the bar before you even start building. And Step 4, rerun the eval on every single change. Let's unpack these so you can actually put them to work.
Steps 1 and 2 are where you really have to roll up your sleeves. First, you need to pull 20 to 50 actual examples. We're talking real support tickets, actual user transcripts. You must avoid synthetic, AI-generated test cases here. Just don't use them. They are way too clean and they completely miss the typos, the weird slang, the bizarre edge cases, the real-world messiness that actually breaks models in production. Once you have those, step 2 is grading by specific failure modes. You can't just do a general vibe check. You have to explicitly name the failure. Was it a hallucinated fact? Was the tone totally off? Did it miss the core ask? Did it leak sensitive user data? You take your real examples and you score them against those exact named failures.
And this is where the absolute magic happens in step 3. Once you have your inputs and your failure modes, you set the bar. You write down a hard rule, something exactly like this. 90% of summaries must capture every action item, and literally 0 are allowed to invent one. See how incredibly powerful that is? You just took the definition of done from a highly subjective opinion and turned it into a cold, hard number. Plus, step 4 means every time you tweak a prompt or update a model, you run this eval. So testing that new change goes from this nervous, I hope it works, gut check, to a precise, automated measurement.
Which brings us to the final piece of the puzzle, Section 5, Shipping with Evidence.
Okay, let's address the elephant in the room here. The absolute hardest part of this entire process isn't really writing the rubric. The real nightmare is sourcing those 50 perfect real-world inputs and actually spotting the recurring failures. As the source material points out, this is exactly the gap that a tool like Specky aims to close. Look at the problem on the left. Your signals are completely scattered. The exact examples you desperately need for your evals are buried deep in Zoom transcripts, Zendesk tickets, and random dashboards. But on the right, we see the solution. Specky turns those scattered signals into a connected product graph. Instead of you manually hunting and guessing at failure patterns, it automatically organizes these examples so they're totally searchable. So if the exact same failure mode ruins 10 different customer calls, you see that pattern instantly. You're not guessing anymore. Hard evidence goes in and reliable evals come out.
Which leaves us with one final, pretty provocative question to ask yourself and your team today. Are you shipping with evidence or are you just shipping with hope? Eval-Driven product managers don't just toss an AI feature over the fence and cross their fingers. They define what good is, they measure relentlessly against it, and they ship with undeniable evidence. It is time we stop treating AI like some magical button and start managing it like the probabilistic system it actually is. Thanks for hanging out with me for this explainer. I really hope it completely shifts how you tackle your next AI product roadmap. Keep learning, keep structuring those evals, and I'll see you next time.